Alright, this lesson on 12.6 is on permutations, combinations, and general counting principles. The main thing I need you to focus on today is not about finishing the homework, but on making sure you understand when to use each of these things. If you look at the worksheets you have, it's 3 counting principles that you need to know, and you need to understand when to use them. The first counting principle is just on general decisions. It is pretty much just in terms of making decisions on counting things whenever you're choosing how many things there are. Getting into that, this symbol here is called a factorial. It's not an exclamation point. I'm not yelling at you to evaluate 5. It's called 5 factorial. And what 5 factorial means is to take 5 times 4 times 3 times 2 times 1. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Again, factorial tells you to go all the way down to the value of 1. That button actually exists in your calculator, and the way you reach it is by hitting the 5 and then going to the probability button, which is PRB, and you see where it has the exclamation point. Go down to it, hit enter to select it, and then hit enter for your answer, and of course your answer is 120. Alright, so if you ever want to know, even if you want to know what 10 factorial is, type the 10 in, hit the probability button, go down to the number 3, choose the exclamation point or the factorial symbol, and it'll give you that answer there. Okay, that is a general problem that you might see on your work, but again, it's just making sure you know how to do it in your calculator, or at least how to evaluate it in general. But a question that we're talking about for general decisions is, it'll be something like, how many different ways can 7 unique items be arranged? In this case, again, you're arranging 7 items and you're making 7 decisions. And so in the general decisions, what you do is, for every decision you make, you put a blank. So there's going to be 7 unique items, so you're going to make 7 choices. So 1, 2, 3, 4, 5, 6, 7 decisions are going to be made. In the first decision, you have 7 things to choose from. But once you choose something, let's say we've got 7 items, 4, 5, 6, 7. So you've got 7 items to choose from, and we choose 1. Alright, so this one's out. Your second choice, you've got 6 to choose from. So let's say I chose that one. Your next choice, you've got 5 to choose from. Your next choice, you've got 4 to choose from, then 3 to choose from, then 2 to choose from, and of course 1 to choose from. And what you see here is, this looks kind of like the factorial, and what you do with your decisions is you pretty much multiply them. So 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is how you would find how many different ways you could arrange 7 unique items. Again, 7 choices, 6 choices, then 5, then 4, then 3, then 2, then 1 is what you're looking at, because every time you make a choice, you take one of your choices away on the next selection. And so if you want this answer, you could type that all in, or you could recognize that since you're going all the way from 7 down to 1, that it's the same as 7 factorial, which is where that comes into play, which is 5040. Alright, so again, in the general decisions section, or anytime you're making just a general decision, how many of these can you choose, and you're making a choice, put a blank for every choice, and then you are simply multiplying every single choice. Now in the computer, you are going to have to, it's going to be 2 boxes on this, and in the first box you need to type this part in, and the second box is where you'll type your 5040. You can use parentheses if you want, or whatever you might do. You could use a multiplication, but just make sure you get that. Again, if you don't know what to do on that, just bring it up to me, I'll show you, and because I've got enough of each one done to where it's giving you practice even after I give you the answer. That's why I give you multiples of each type of question. 14 members of student council, how many ways can a president, vice president, and treasurer be chosen? Again, this is a general decision because you're making 3 choices. You're choosing a president, you're choosing a vice president, and you're choosing a treasurer. Again, general decisions is just blanks. That means you're making a choice, so put a blank down for every choice. How many people do I have to choose from for the president? 14 people. How many people do I have to choose for the vice president? Well, once I chose a president, there are now only 13 people. And then for the treasurer, well, if I've chosen from here, there is now 12. And so you can kind of see the pattern on your general decisions, where all it is every decision just goes down 1. But in this case, you're only making 3 choices, and so that's where you need to make sure you're paying attention to how you set it up. So we just do 14 13, 12, which is 2184. Another general decision. Phone comes in 5 colors, 3 key styles, 4 exterior patterns, and a choice of Google Play or iTunes. How many different phones are there to choose from? In this situation here, again, you are now making a choice on the color. All right. You're making a choice on the key style. You're making a choice on the exterior pattern, and then you're making a choice on whether you want Google Play or iTunes. So 4 choices. You're choosing the color, the key style, the exterior pattern, and what you want in terms of your app decision. And so what you have to do now after you determine how many decisions you make is fill out each part. I have 5 choices on the first decision. I have 3 choices on the second decision. I have 4 choices on the third decision, and most questions will try to hide the 4th choice, and you have to kind of read it. It says a choice of Google Play, which is one option, or iTunes, which is a second option, so there's 2 choices there. And again, once you have that, you're going to multiply those things out. And find out that there are 120 options for you to choose from. Alright. Again, what you want to do is take these notes well, go to your homework after you're done, and make sure you try to work on figuring out when to use each part. I'm giving you these because each of these questions, excuse me, each of these questions is different. 9 men, 6 women who have applied for a commercial. How many husband-wife couples are there to be chosen from? Again, we're choosing husband-wife couples, which means we're choosing a husband, we're choosing a wife. We have 9 men to choose from, 6 women to choose from, and of course, if you multiply that, there are 54 total ways that we can do that. So again, this was your general decisions part. Anytime you're making a decision, just put a blank for every decision and multiply those blanks. The second principle is what we call permutations. In permutations, the order is important. We'll talk about what that means as we get there. But again, in permutations, order is important, and the way I think about it is in the alphabet, O for order leads to the letter P for permutation, because O and P are right next to each other in the alphabet, O, P, Q, R, S, T, U, V, whatever. So anytime order is important, I try to remember this a permutation, because there's another one we're going to see after this where order is not important. First off, how do you evaluate 14P3? Well, what you do is you type in the 14 first. You go to your probability, because that's pretty much what this section is under. You choose the NPR. So that puts 14 in for the N, and then you put the next number, which is 13, or 3, for your last part, which gives you the answer 2184. Now take a moment and look back at number 3, which talks about 14 members of a student council. Think about the fact that you had 14 people to choose from, and you chose 3 people. That is how a permutation makes this easier. Notice how the answer is 2184 on this one. Notice how the answer is 2184. So this, again, is kind of like a general decision part here, because it does matter when you get selected. It does matter in this situation that the first person selected is a president, the second person selected is a vice president, the third person selected is a treasurer, because if you were to switch those 3 people around, they would be in different offices. So again, when order is important, that's what you would do, and what that means is you have a group of 14 things and you're choosing 3. Alright, so looking at number 7, 10 books in your summer reading list. How many different ways can you choose to read 4 books over the summer? Again, in this case, the order is important because it does matter whether you read the second version of a book before the first version of the book. So what we're looking at here is we have 10 books to choose from. Order is important, so we choose P, and we are reading 4. And so we do 10P4. Again, PRB, select NPR with the 4, gives me 5,040. But keep in mind, there is a second way to do this, which is where you make a choice of 4 books with 10 to choose from, then 9, then 8, then 7, which would also give you the same answer. The nice thing about these first 2 is that they actually are the same thing. It's just that it depends on your level of practice. If you practice using this, you'll be good at it. The safest one to always use is this one, because whenever things get crazy, this will always work, whereas this doesn't always work. 7 members taking a photo, how many different ways can the members be lined up? Again, you're talking about 7 people to choose from, and if you're taking the whole photo, then of course you're choosing all 7 people, because again, putting the youngest first versus putting the oldest first does matter, so order is important. So you do 7 PRB 7, which is your 5040 here. The way you offset that is by doing 7, 6, 5, 4, 3, 2, 1, which if you were to type that in, I'm pretty sure you would get the same answer there also. The last counting principle is what we call combinations, and this is where order is not important, which I'm going to discuss once I get to those 2 questions. First off, how do you evaluate 11C4? It's similar to 11P4. Type in the 11, hit the probability button, and choose NCR instead of NPR, and then type your 4, and that gives me the answer of 330. Now, there are stars on these because these 2 questions are similar to the ones that have the stars. So the first one is similar to number 3. If you go back up to the 14 members, it's just slightly different. 14 members of student council, how many ways can we choose 3 representatives? Here's the thing. In the first one, we had president, vice president, treasurer, which all 3 of them had different powers. In this situation, everybody is balanced, so it doesn't matter whether you were picked first or picked last, you get the same type of reward. So therefore, that is why order is important, or is not important, and so we choose a combination. All right, so 14C3 is what we're looking at here, which gives us the answer of 364 different combinations can be chosen. Again, order is not important. Don't think of a combination like a combination lock. That doesn't work. That confused me when I was in school. Think about a combination as order is not important, so I'm using the C. Order is important, so I'm using P. Alright? And then 11 is similar to number 7, where you're talking about your summer reading list, but this is 8 books in your locker. How many different ways can you choose 3 to carry? Well, here's the thing. Does it matter if I choose the math book first, biology second, history third, or history first, math second, whatever, because I'm carrying them in my arms. So it doesn't matter when I choose the book. It's just the fact that I actually choose the book. So in this case, you're choosing from 8 books. And again, you could say choosing 3. And so you would use 8C3. And your answer would be 56. Again, I need you to understand that your point for today is not to finish. Your point is to make sure you understand when to use the blanks, when to use NPR, when to use NCR. Trial and error, of course, is what I really set you up for, which is why I want to give you these notes so you can kind of look and see. If you can't do it on your own, come and see me. I'll try to help you out, but just make sure you're working on trying to understand the general idea. Other than that, go ahead and go to your Math Excel, and again, let's get started on our practice. Good luck.